Assalamualaikum and hi. I will be presenting my paper study with title of Biodegradable Packaging Tray derived from Napier grass fiber in terms of mechanical properties. So firstly, let me introduce myself. My name is SITI Hidayah binti Jamel and currently I am a Bachelor of Manufacturing Engineering Technology student. I am supervised under Dr. Ridwan bin Jumaidin. The content included in this presentation consists of 5 chapters. In Chapter 1, it covered for background, problem statement, objective of study and scope of study. For Chapter 2, the subtopic covered are starch, thermoplastic cassava starch, Napier grass and its applications. The Chapter 3 covers for material and sample preparations, while Chapter 4 covers for mechanical, thermal and physical properties. Lastly, for Chapter 5, the topics covered are the conclusions and its product potentials. In year 2015, the annual production of petroleum-based plastic exceeded 300 million tons, with less than 1% being bioplastic. In light of environmental construction, it is necessary to design a product foundation based on biodegradable materials. Furthermore, in landfills, non-biodegradable materials such as plastic disintegrate over hundreds of years. Thus, thermoplastic starch, which also known as TPS, can now be seen as a new class of low-cost and environmentally friendly polymers that can be restored to their original condition without causing any pollutions. For the problem statement, it is divided into 3 cases, which is firstly, high consumption of petroleum-based. This explains why critical issues are increasing due to widespread plastic use. The second problem is insufficient performance of thermoplastic starch. Thermoplastic starch is a new class of low-cost and environmental friendly polymers that can be restored to their original condition without causing any pollutions. Thus, it is suitable material to be widely used in industry nowadays. The third case is agriculture Napier grass waste. This can be seen by the minimal usage of applications of Napier grass, and in the end, Napier grass is used just to provide sustainable livestock. The objective of this study are such as to produce biodegradable TPCS reinforced with Napier grass fiber composites. Next is to investigate the mechanical and thermal properties. And lastly is to produce a biodegradable packaging tray of TPCS from the Napier grass fiber composite. For the scope of study, the cassava starch used was tend to minimize the problems created by the typical thermoplastic structure, while the incorporate of beeswax was to reduce the moisture sensitivity from thermoplastic cassava starch. In terms of mechanical testing, the test carried out is thermal, mechanical, and physical properties. For mechanical testing, there are tensile and flexural testing, while for thermal properties, the testing included is thermogravimetric analysis. Furthermore, the physical testing that have been done are scanning electroscopy, microscope SEM, Fourier transform infrared spectroscopy FTIR, and the fabrication of packaging tray. Starch was generated from carbon dioxide and water by photosynthesis in plants. It is also low cost and renewability. Furthermore, it stands out as a potential biopolymer matrix for the manufacture of edible plastics due to its ubiquitous, cheap, and biodegradable nature. In addition, it consists of amylose and amylose pectin. Thermoplastic cassava starch, or also known as TPCS, is a hydrophilic substance. TPCS also is a material created when the structure of the starch granules is disturbed, which can be means as modified by heat and mechanical pressure in the presence of plasticizer. Furthermore, it is a great promise as a green material for environmental friendly packaging. TPCS is also a biodegradable and durable material. This is some examples of thermoplastic cassava starch usage in different studies. Napier grass, or also known as elephant grass, is a species of perennial grass which is native to subtropical Africa. Napier grass also is abundant and fast-growing plant with significant potential as a renewable energy source for conversion to higher calorific value fuels. Furthermore, Napier grass is easy to grow, more adaptable and productive grass, which is very suitable for the Malaysia conditions. It also provides a high biomass yield in the most tropical and subtropical climates and already well known as well as usage of livestock fodder. It also provides a high biomass yield in most tropical and subtropical climates and already well known as well as usage of livestock fodder. Here is some applications examples of Napier grass fiber in paper, packaging product, car doors, and also base panels. This is the flow chart of this paper study. The process starts with harvesting the raw material, which is Napier grass. Then the process continues with mixing the cassava starch, beeswax, and glycerol to form the TPCS mixture. The mixture then will press using hot compression machine for 60 minutes. The process continues for 0, 10, 20, 30, 40, and 50% of fiber content. Next, the samples done will undergo various types of analysis such as tensile, flexural, TGA, FTIR, SEM, and lastly was the fabrication of the biodegradable packaging tray. Next, this was the procedure done for extracting the Napier grass fiber. Firstly, the raw material for this study, which is Napier grass, was collected. Then, the stem collected will undergo by water retting process for 3 to 4 weeks. After that, they were dried up under the direct of sunlight. For maximum drying, the Napier stem were dried in the oven for 6 hours at 105 degrees Celsius. The stem then was smashed and cut into small pieces before grinding it to obtain the fine Napier grass fiber. Other than Napier grass fiber, the material used in this study are such as cassava starch, glycerol, and beeswax. So, for the preparations of TPCS mixture, the procedure included are such as wetting the cassava starch, glycerol, and beeswax before mixing it up together by the dry mixing for 3 to 5 minutes. After that, for the fabrication of TPCS mixture, the procedure included are such as compacting the mixture into the mold, covering it up with mylar film before placing it into the hot compression machine to form the samples. Meanwhile, for the fabrication of TPCS mixture reinforced with Napier grass fiber, the process included are such as wetting the TPCS mixture, the Napier grass fiber, and lastly, compact it into the mold before placing it into the hot compression machine for the samples to be done. In terms of thermal properties, the thermogravimetric analysis was used to determine the thermal stability of the materials. It is an analytical technique for determining the thermal stability and volatile component percentage of a sample by estimating the weight change that occurs at a constant rate when the samples are heated. The mechanical properties consist of two testing, which are tensile properties and flexural properties. Both of these properties were using the same machine with different operation tools, which name is Universal Testing Machine, or also known as Instron 596-9. Meanwhile, in physical properties, the tests included are FTIR and SEM. For the FTIR, the tests conducted are using JASCO FTIR 6100 IR spectrometer, while in the SEM analysis were conducted using ZIS EVO 18 scanning electron microscope. For the tensile properties, the tensile strength and modulus shows a similar increasing trend, while tensile elongation shows a decreasing pattern. This might be due to the fact that the fiber and matrix are both hydrophilic, resulting in excellent bonding. Meanwhile, the reduction in elongation following Napier grass fiber inclusion may be due to fiber matrix bonding, which prevents the material from undergoing substantial elongation. As a result, the composite developed a lower ductility than the TPCS matrix. As for flexural properties, generally a similar trend in the tensile and flexural characteristics of the Napier grass fiber composites was found, which the flexural strength and modulus of Napier grass fiber composites shown a increased trend. The improvement in the flexural characteristics of the Napier grass fiber composites might be attributed to the same causes as the increase in the tensile properties. Thus, the flexural graph results agreed with the tensile graph results in strength and modulus because when the strength increases, the strain will be decreased. In terms of thermal properties, the increasing percentage of Napier grass fiber in the TPCS matrix improved the thermal stability of the composites. This might be due to the inclusion of fiber improved the thermal stability as seen by the increased residue content. Moreover, the fact that the fiber is less, it is more water resistant and stronger than starch. The FTIR analysis result shows that the wave number of OH bands increase when the fiber concentration rise. A study from Pola and Mocha discovered that the presence of hydrogen bonds occurred with the addition of fiber. Hence, it improved the mechanical characteristics of the composites. The presence of OH bonding in the biocomposite by FTIR analysis was also demonstrated by the substantial interactions of intermolecular hydrogen bonds exist between TPCS and fiber composites. In terms of SEM analysis, it shows that the increasing fiber content in the TPCS and Napier grass fiber indicates that the sample's composites have a distinct microstructure. Moreover, the inclusion of glycerol increased starch plasticization as well as the starch melt mixing. The presence of voids explains the inclusion in tensile strengths after the tensile properties is done. Thus, it was demonstrated that increasing the fiber loading enhanced the composite's flexural and tensile strength using SEM micrographs. At the end of this study, a biodegradable-based composite packaging tray derived from TPCS and Napier grass fiber was successfully prepared. The study also revealed that the mechanical testing of TPCS showed that the tensile and flexural properties were improved, while the elongation properties was reduced with the addition of Napier grass fiber. In terms of thermal properties, it was discovered that the increasing percentage of Napier grass fiber in the TPCS matrix improved the thermal stability of the composites due to the fiber's hydrophilic qualities. It is also might be due to an increase in residue content, which indicates increasement in fiber content. The FTIR analysis demonstrates the presence of chemical bonding in the samples. Scanning electron micrograph, or also known as SEM, that has studied the tensile fracture shows a good fiber matrix addition and efficient stress transfer from matrix to fiber. Overall, the addition of Napier grass fiber in TPCS improves the mechanical, thermal, and physical properties of the composite, which it widens the potential application of this biodegradable material. This is the proof of surveys that have been done on packaging tray application at FZ Enterprise, while this is the proof of surveys that have been done on packaging tray application at Sophia Tomyam. From the survey, both companies, which is FZ Enterprise and Sophia Tomyam, were agreed to purchase the product for RM2 each pieces. This is the Gantt chart done for PSM1, which showing the process flow week by week during completing PSM1. Meanwhile, this is the Gantt chart done for PSM2, which also showing the process flow week by week during completing PSM2. Last but not least, that's all for this thesis study presentation. Thank you and have a good day.